Hello students. We want to look at vector algebra part 2. Some Ibra questions under vector algebra. Now, let me first start with how to find the magnitude of a vector. How to find the magnitude of a vector, or the size of a vector, or the absolute value of a vector. Now, for example, what is the magnitude of the vector A equal to 1 and 4? Okay, let me use minus 4. What is the magnitude of this vector? A equal to 1 minus 4. So I want to write magnitude. I may try to write it this way. Is it something like this? It means what is the magnitude of that vector? So the magnitude is the square root of this s component. Then you square it, plus this y component. But you will do away with the sign. Don't take the sign along, because if you take the sign and you square everything, it will still change to plus at the end of the day. So because of that, in order to avoid the distractions, just leave the sign. When you are doing magnitude, just forget about the sign, take only the value and square it. That will give us root 1 plus 16. That will give us root 17. So this is the magnitude, or the absolute value, of this vector. Now let's look at this other question. Now let's say if x is equals to, if s is equal to 3 comma minus 2, this is 3 comma minus 2, and y is equals to 1 comma minus 4, that's y is equals to 1 comma minus 4, that's minus 4, and z is equals to 1 comma 4, 1 comma 4. Okay, let's say find the value of 2x plus y minus z. Find the value of 2s plus y minus z. So what will be the value of this? That's what we are looking at now. So let's look at it. We're having 2x, that will be equal to 2x. So what is x? Okay, let me write it as I see it. We have 2x minus y, okay, plus y is plus y minus z. So we have, that will be, okay, let me write it here. This will be equal to 2. What is x? Look at this here. That is 2 comma minus 3. That is 3 comma minus 2. 3 comma minus 2 plus y. What is y? Look at y here. That is 1 comma minus 4 minus z. And which one is z? Look at z here. 1 comma 4. 1 comma 4. That is z. So this will give us 2 times 3. What is that? That is 6. That is 6. 2 times minus 2. That is minus 4. Plus 1 comma 4. That's 1 comma 4. Minus 1 comma, okay, 1 comma minus 4 first. This other one is minus 1 comma 4. So the next thing, we add this, work them, to work this, and this. So let's go. So this will give us something very nice. To go something very Very nice. Now 6 plus 1, that is 8, minus 1, that is 6. That is 6 already. So that will give us 6, comma, minus 4 plus minus 4, that's minus 8. Minus 8 minus, that's minus 12. The answer will be minus 12. So that will be the answer to this. So that is the answer to that question. So please you take note of that. It's very, 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 very important. Very, very what? Important. Now, how about to now have this question? How about to have this? Let's say we're having this. X is equal to 3 comma minus 2, y is equal to 2 comma minus 4, z is equal to minus 1 comma 4. What is 2x plus y plus 2z? 2z. So how are we going to do this? This will be equal to 2x. Let me just do it here. That will be equal to 2x. What is x? 3 comma minus 2 plus y 2 comma minus 4 plus 2z minus 1 comma 4. So it will give us this times this, that is 6. This times this, 2 times, that is minus 4 plus 2 comma minus 4 plus this times this, that's minus 2. This times this, that is 8. So we can give us 6 plus 2 minus 2. That is 6 plus 2 plus minus 2. That will give us 6 minus 4 plus minus 4. That is minus 8. Minus 8 plus 8, that will be 0. So I'm going to have 6 comma 0 as the answer to this. So let's us take this question now. Let's we have this question. Let's we have this question. If j, let me just write j like this. If j is equals to minus 1 comma 3, comma, full stop, let me just say full stop, and jk, that is vector jk is equals to minus 5 comma 2, then find k. What is the meaning of k? What is k? If j is this and jk is this, remember jk is equals to, about the what we did, jk must be equal to this minus this. That is the last one minus the first one. That will be equal to k minus j. Let me just write j like this. So if you do this now, we are going to have, want to make k the same formula now, be? Yeah, make k the same formula. So k will be equal to jk plus j. We move this one to this side. Then minus we change to plus. So that will be equal to, what is jk? Minus 5, comma 2, plus, what is j? Look at j here. That is minus 1, comma 3. You can also write it this way. This one you are seeing here now can also be written like this. I explained that in the last class we did. So just work this and this together. So we're going to have minus 5 minus 1. We're going to have minus 6. 2 plus 3. That is minus 5 plus minus 1. That is minus 6. 2 plus 3 give us 5. So we are going to have minus 6, 5 as the value for k. So, alright, let's look at this next question. Look at this next one. Let's say if PQ is equals to 5 and 3, 5, 3, and Q is equals to 2, minus 4. Yes, 2, minus 4. Find P. Find P. What is P? So remember PQ is equals to Q minus P. I don't know if you can remember that. Is this minus this. Such that P now, if you move P to this side, I move this one to this other side, we are going to have something like this. P will become plus if you come to this side. Then Q minus. This one become minus because we're already plus here before. So minus PQ. So that will be equal to. Let me solve it here. Let's clean this part. That is Q first. This one, that's Q first. That's first you're going right now. That's Q first. So Q is what? Q is 2, minus 4, minus PQ. Now where's PQ? 5, 3. So 2 minus 5, what is that? That's minus 3. 4, okay, minus 4 minus 3, that's minus 7. This way I'm going to have minus 3 minus 7. That is the answer to it. Minus 3 minus 7. So let's look at this other question. Next question. I hope this one is very clear. Just know that if you have something like this, if you want to express, let's say PQ now, it is this last one minus this first one. That's how to express vector. Vector AB is equal to B minus A. That's how it is done. So let's look at this. Let's look at this. Let's say we have let's say ABCD is a parallelogram. ABCD is a parallelogram in which that AB is equals to minus 7, minus 3. BC is equals to 6, minus 2. Find the vector AC. Find the vector AC. Now this one now, we are going to use line vector to do this. We're going to use line vector to do this. AC is same thing as C minus A. This one is when you are using just single vectors for A, B, and all that. Since we have a vector that have maybe moving from one point to another now, we're going to just solve them using line vectors. So AC now will be same thing as, let's say, AB plus BC. That is AC. AB plus BC. This B should be here as well. This is how to do it. I don't know if you have done line vector before. I don't know if you have done line vectors before. We are doing line vectors where this first one end, this other one will start from there. Where this one end, now if I want to add another one to it now, it will start from C, maybe CD. If I want to add another one now, we'll start from D, we end at E. So the total vector now for this one so far now will be AE. So if I don't add this, if I decide not to add this one, for this one the total vector will be AD. If I decide not to add this one, for this one the total vector will be AC. That's how line vectors are done. So please take note of that. It's very, very important. So this one is simple enough. It's very simple. So let's just finish it up to get the final answer. So we're going to have AB is already this. We're going to have this plus BC is already this. So let's just add together now. This plus this. 6. Okay, let's say minus 12 plus that is minus 1. That's minus 1. That's minus 1. Minus 2 plus minus 3. That's minus 2 minus 3. That's minus 5. So that's minus 1 minus 5. That's what you're going to have as your answer. So please take note of this line vector. This one is different from the ones we have been doing things. So you have to look at these questions and ensure you are already good to go. Let's look at this as well. Look at this next one. Let's see if s is equals to 3, 5 and y is equals to 7, 1. Find sy. So can you express this sy now? Because s and y are given separately. If you want to find sy now, sy is supposed to be, let's say, a plus ay. So now will be x, y. Since one is just giving us single vectors s and y, we can also do it this way. The best way to do this one now is just to do it like this. Sy now will be y minus x. Simple as that. That will be y minus x, which is dx minus, okay, let me just write it, 7, 1 minus 3, 5. 3, 5. So that will give us 7 minus 3. That is 4, 1 minus 5. That is minus 4. So that's 1, minus, that is 4, minus 4. That is the answer to that. So another question we're still going to do. We still have another question to do in this place. Now we are still in vector operation. Say vector operation, vector algebra, and the rest. Now there's a question I want to look at quickly. The question is to find the unit vector which is parallel to the vector. Find the unit vector which is parallel to the vector 7i minus 4j. The question is, what unit vector is parallel to this vector 7i minus 4j? Now the unit vector that is parallel to this vector now, let me call this vector A. What is the unit vector that is parallel to this vector? A is equals to 7i minus 4j. Now the unit vector parallel to this, this vector parallel to this A now is written, I can write it this way, which is the vector A. This one is vector A. The vector A divided by the magnitude of A. This is the unit vector parallel to A. Vector A divided by the magnitude of A, which will be equal to, what is vector A? 7i minus 4j divided by the magnitude of A is what? 7 square. I told you for magnitude we don't use minus, so forget about minus, plus 4 square. Then forget about all these ijk vectors. All those ones are just for directions. So just pick only this and this. Like the first magnitude we do, that was the first that was our first example here. So that will give us 7i minus 4j over the square root of 7 square is 49 and 4 square is 16. So 49 plus 16. So what is the answer to that? So if you do that very well, you are going to have something very, very nice, which is 65. So I can also write this one like this way. I can also write it like this: 7i over root 65 minus 4j over root 65. Also write it like this: 7i over root 65 minus 4j over root 65. That is the unit vector parallel to that vector that was mentioned in that question. Now, there is another question here we want to look at. Another important question in this place, which is we are told that given that 7i, given that a is equals to 7i minus 3j and b is equals to 5i plus 7j, find 3a plus b. Find what? 3a plus what? Plus b. So this will be equal to 3a. What is a? 7i minus 3j. This is vector algebra. Plus b. What is b? 5i plus 7j. So that will give us 3 times 7, that is 21i. 3 times this, 3 times 3, that is minus 9j. Plus 5i plus 7j. So the next thing, add I to I, add j to j. We're going to have 21 plus 5. That will give us 26i. Minus 9 plus 7. That will give us minus 2j. Any calculator, if you know you don't know how to use your head to calculate, you have to use calculator. So that will give us 26i minus 2j. That's what we are going to have. 26i minus what? Minus 2j. Now find the resultant. Another question. Let's find the resultant of these vectors. Find the resultant of the vectors. A is equals to 3i. A is equal to 3i. B is equals to minus 2i minus j. Minus 2i minus j. C is equals to I plus 4j. So what is the resultant of these three vectors? Resultant means when you get the total, that means what is the total of these three vectors? That's what we are talking about here. What is the total of these three vectors? The total will be A plus B plus C, which is 3i plus B, which is minus 2i minus j minus 2i minus 2i minus j plus C, which is I plus 4j. So let's add I to I to I. What I'm going to have? 3 minus, 3 plus minus 2, that is 3 minus 2, that is 1. 1 plus 1, that is 1 plus 1i, that is 2i. Then let's check for j now. Let's check. That's it. We have minus 1j plus 4j. Minus 1 plus 4, that is plus 3j. So we're going to have 2i plus 3j. That's the resultant of those 3 vectors. So you take note of that. Now look at to find the product. Find the scalar product of the vectors. To find the scalar product of the vector, although I've already done that class, it's already inside this channel. How to find dot product or scalar product. Find the scalar product of the vector minus 2i plus 3j and 4i plus 5j. So they are telling us what is the scalar product, means what is 2i plus 3j dot 4i plus 5j. So we are going to dot this one to this, multiply this one to this. So minus 2 times 4, what is that? That will give us minus 8. Minus 8. I dot I will be 1. If you dot I, it will cancel out, it will be 1. So plus 3 times 5, what is that? Plus 15. If you dot j and j, it will also cancel out. So we are going to have, it will be 1. So we are going to have minus 8 plus 15. That will give us 7. That's why I'm going to have 7. So please, you take note of that. The dot product will be equal to plus 7. That is the dot product of those two vectors. Please take note of that. It's very, 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 very important. Very, very important. Now, we have to find the unit vector acting in the direction of this vector. Find the unit vector acting in the direction of this vector. 2i minus j. Find the unit vector acting in the direction of this vector. The unit vector is t equal to, let's say if we call this one now vector a, is still that vector a, divided by the magnitude of a. And the first one we do for the vector parallel to this vector. So that will be vector a is 2i minus j divided by the magnitude of this. What is the magnitude of this vector? Pick this one, you square it. Then plus, what about this one? What is here? We have 1 here. That is minus 1j. I told you don't use minus in the resultant. Just pick the one, you square it. So that will give us 2i minus j over the square root of 2 square is 4, 1 square is 1, that is 5. This is the unit vector acting in the direction of that vector. So you please take note of that. I think we are going to stop here. We're going to stop here. So I'll see you guys in the next class. Thank you.